Hi, everybody. So the packet I handed out to you on Monday is the one I want you to go get. And so hit pause on this and then run and go get what you need to get. There's one change I want to make on this particular problem where it says segment RC is being dilated by a scale factor of 2, who has coordinates 6, -1, and 3, -6, and the center of dilation is at -2, 0. I actually want you to change the center of dilation to be at -1, 2. Okay? At -1, 2. That's where I want the center to be. So make sure you change that before we go on. So the first thing we're going to do is we're taking this segment. Now, before we've been dilating lines, right? And the interesting thing about lines is we always talked about how you can't make a line bigger because a line goes on forever and ever. And when we dilated lines, it was about being further or closer to the center of dilation. Whereas a segment, you can make it bigger or you can make it smaller. So when it says we're taking this segment RC and we're dilating it by a scale factor of 2, that means the length of this new segment should be, you guessed it, 2 times bigger than the original. And we're going to confirm if that's true or not. So make sure you have your calculators ready as well. Okay. So for starters, let's actually grab the segment and plot the center of dilation. So 6, -1 is putting me here. I'm glad I have my glasses on, you guys, because otherwise I can't see. And then 3, -6 is going to put me down here. So, no, that's not 3, -6. Wait a minute. 1, 2, 3, 4, 5, 6. It's right here. Oops. So this is C right here. As I said, thank God I have my glasses on so I can actually read what I'm doing here. So I'm going to connect the dots from here to here. So that's C and that's R. And then I said I wanted to put the center of dilation at -1, 2. I changed I don't want it to be at -1, 2. I want it to be a little bit closer because I'm afraid I'm going to be going off the paper. You know how I continue to go off the paper because I do that? So we're actually going to change the the center of dilation to 2, -1. So my dyslexia is kicking in. So we're going to go 2, -1. So I hope you guys are paying attention. This is a good exercise for you guys to listen. This is phenomenal. So my center of dilation is at 2, -1. So 2, -1 is right here. So now it's time for us to go ahead and let's dilate this segment, right? And so in other words, when we dilate the segment, because the scale factor is 2, the length of this segment should be twice the size as the new segment should be twice the size of this one here. So what I like to do, and I think we've talked about this, is we count the slope, like the vertical and horizontal distance it takes to get from the center of dilation to that point. So 1, 2, 3, 4, 5, right? So 1, 2, 3, 4. This is 5 units vertically and 1 unit horizontally. So if my scale factor is 2, that means I'm going to multiply those by 2. So now it's going to be 10 from my center because this here is my little center, right? So 5, that's going to be 10. So this is already 5, 6, 7, 8, 9. Yes, go down one more, you guys. You know the drill. So we're down here at -11, right? And then over 1, 2. So we're going to be over here at this point. So this is going to be C prime right here. So C prime, because again, you went down 10 and to the right 2 because we originally went down 5 and to the right 1. So my new ordered pair is going to be 1, 2, 3, 4, comma, -11 is my new point, okay? Now, from the center to R is actually really cute because it's only on a horizontal and we are 4 units away here. So I'm going to multiply that by 2. So now we're just going to be 8 units away horizontally for R prime. So since this is already 4, we're going to count 1, 2, 3, 4 more out here. And this right here is our R prime. So now when I play connect the dots, that's it, Connor. Sing it la 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 because you're the one who always does la 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 with me. So when you look at that, these are, I'm just so cute with my color coordination right now. This is the original line and this is the new line. And this is my center right here. So the argument is that, you know, this segment should be half the size of this, which means this should be twice the size of that. So let's actually go ahead and confirm it, shall we? Okay, so what I'm going to do is if you go back to your good old Pythag swag, we do our little horizontal and vertical. So we're going to go over 1, 2, 3. So this is 3. 1, 2, 3, 4, 5 is 5 here. So if we do Pythag swag off here, it's going to be 3 squared plus 5 squared is equal to x squared. That's 9 and 25, which is 34, equals x squared. So the length of this segment is the square root of 34, okay? Now, if we do this one over here, again, we're going to do our vertical and our horizontal distances, right? So if I'm here at we're going to count 1, 2, 3, 4, 5, 6. So this is going to be 6. And then if I count this, this is going to be 10. And what's interesting, if you're noticing, those vertical and horizontal distances are double. It's no accident, okay? So, and we're just going to confirm it again. So we're going to do 6 squared plus 10 squared is equal to x squared. So that's 36, that's 100. So this is 136. So the square root of 136 is equal to x, So this is the square root of 136. And if you're staring at the two of them, you're like, wait a minute. I don't know if one's twice the other or one's half of the other. So take out your trusty calculator. And if you take the square root of 34, you're going to have 5.83. So this is about, remember, 5.83. Which means if this is twice that, this should be about 11.66. So we're saying that should be about 11.66 because I multiplied my answer by 2. So now I'm going to confirm by doing the square root of 136, and I want you guys to do the same thing. And sure enough, you get the 11.66, blah, 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 blah. Okay? Now, something else that I want you to notice that is absolutely spectacular when we're dilating segments is if you take a ruler, right, or if you take 2 pencils or 2 pens or anything like that, if this is the old image and this is the new image under the dilation from the center, you will be able to draw a line through all 3 points. So if you were to take your ruler and connect, you'll be able to make those all intersect, and they're going to be connecting through the same line. And then the same thing with R and R prime, they're all going to be able to be collinear. Collinear means they all lie on the same line. So I could go ahead here, and if I were to take a ruler, it's going to go through all 3 points, right? So in other words, the center, the old image, the old point, the new point, and the same thing down here. And if you notice, those lines are all going to intersect at the center of dilation. Which brings me to the next problem. So here we go. Go to this one here, guys. So take this guy out here. Get this one. All right. XY has been dilated. And let's do an analysis even before we begin. So this segment XY has been dilated, and this is the new image. So if this is the new image, that means the scale factor, because that's what we're on the hunt for, right? We're looking for the center of dilation, and we're looking for the scale factor. One thing you should be able to determine about the scale factor is that the scale factor is going to be, you guessed it, is going to be less than 1 because your new segment is smaller than your original segment. So one of the things that I like to do again is, if you think about it, these 2 points, if you take your ruler and draw a line through, going through here, and then you take another one, your ruler, and draw a line through here, those lines should intersect at a point, and that point should be the, you got it, the center of dilation. So I don't have a ruler handy dandy, but I'm going to use my stapler, but I'm assuming you guys do it too. So hit pause, and let's see if we wind up with the same center of dilation. So I'll see you guys in just a moment. Okay, here we go. And you can actually see, it's going to be nice, the center dilation. This blue pen is so pretty, the way it writes. It's just such a gorgeous pen. And you can actually see, did you guys get a center of dilation at 5, -4? Did you get that as your center? Did you guys get the center that I got? I hope so. So now that takes care of the first part. So again, remember, you're going to be able to draw lines through, and that's going to happen, which is delicious. Okay? Now, so that takes care of this, part A. And now we're going to go to part B, or number 2. It says, let's find the scale factor. So with the scale factor, there's 2 ways that you can go ahead and approach this. So one of them is, like, again, you can either count vertically or horizontally. It doesn't matter. And if you remember, your scale factor is equal to new over old. Now, in this case, we have horizontal and vertical distances. So if you want to do your scale factor, you're going to do new horizontal over old horizontal, or you could do new vertical over old vertical. Now, I strongly suggest you check it for both just to make sure that what you're doing is correct. So, and it doesn't matter if you check it for X prime or X, or if you check it for Y prime or Y. Take your pick. I personally, I'm looking at the Y's, and what I like about the Y's is that they hit really nice points, and this one hits a fraction, so it might be a little bit easier to do it that way, but I think I'm going to do both for you, okay? So again, if I do this and I'm like, okay, I'll do from y and y prime. So if I count vertically up, right? If I count vertically up, I'm going up 1, 2, 3, 4, 5, 6, 7, 8. So that's 8, which is my old, right? And remember, it's new over old. And then I'm going to do my new, so it's 1, 2, 3, 4. So this is equal to 4 over 8. So according to this, my scale factor is 1/2. So let's confirm that by doing the horizontal for the same thing. So again, if I go up and over, this is 2. If I go up and over, my horizontal is 1. So my old over my, my old over my new, again, is still 1 over 2. So my scale factor turned out to be 1/2 over here. Now let's confirm it on the other guy. So if I go across here to x, if I go all the way out to x, I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9. And then if I go out to my new image, I'm going out 1, 2, 3, 4.5. So this is 4.5. Well, ladies and gentlemen, 4.5 divided by 9 is 1/2. And then the same thing if you were to do it on a vertical. I'm going to pick up that beautiful blue pen that I just love so much. And if I go up vertically, that's 1.5. That's my new. If I go up vertically here, my old. So again, my old divided by, my new divided by my old, again, is going to be 1.5 divided by 3, which is equal to 1/2. So if you notice, every single one of those ratios comes out to be 1/2. I strongly suggest you check for 2 of them. You don't have to check for all 4. So that means then that your scale factor is 1/2, and it should make sense because at the beginning we said the new image, right? Here's the new image is smaller than the old image, so therefore your scale factor does need to be less than 1, and sure enough, it was actually less than 1. Now you could also go ahead and check to see if the lengths of your segments, if this, whatever this is going to be half that, and again, you can do that using Pythag swag. All right, so where are we here? Here we go. So now let's get crazy and let's do this one here where we're dilating a rectangle by a factor of 3. So we're actually going to dilate an entire shape by 3. And we're using -12, 3 as our center of dilation. So here, if I count out, this is 10, 11, 12, and then 1, 2, 3, right there. So this is my center here. I'm going to call this my center. It's always nice to label the center. So again, if you want your rectangle to be dilated by a scale factor of 3, that means your new rectangle should be 3 times the size as the old one. So again, we're going to do this point by point like we did before. So again, I'm going to go ahead and I'm going to say, okay, to get to A, we go up 1, 2, 3, 4, 5, 6, over to the right 2, so this is 6 and 2. So because it's a scale factor of 3, they're being multiplied by 3. So from your center, always count from where, folks? You got it. From your center, you're going to count up 18. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Just made it to the top and to the right. 1, 2, 3, 4, 5, 6. So here's A, okay? I feel like we're going off the paper. This always happens, right, when we're doing these things. So it's absolutely out of control. Anyway, so the same thing with D. So D, you're going to count how far over you have to go, how far up you have to go. So we're going 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. So that means you're going to be going 18 and 18. Yes, so we're going to count out 18 and going up 18 from your, you guessed it, from your center. So you're going to go all the way out. So 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I'm right here. Okay, so here's D. Okay, and it makes sense because it should be on the same line, right? And then C, if you think about it, you're going to be counting over to the right 6, but then up because it's 3 more 9. So this is going to be like a 9. So you're going to go 27. Whew, that's 27 up. So you're going to be up here somewhere. As you can tell, we're going to be going off the paper. But again, take your ruler, extend everything out. So when you're done, you should be, it should be something like this when you're done. Where this is B, this is C over here, and when you draw your thing, this rectangle is going to wind up being 3 times of what it was. And what's more is, again, you can draw a line through those, a line through the B prime, the center. You'll be able to draw a line through the center, D and D prime. This is D prime. These are all primes. I don't know why I didn't put primes on here. So again, when you're doing this, everything stems from the center. And whatever your scale factor is, you count your vertical and your horizontal distances when you do that. So there's a packet that it was left on my desk, and it's online, but ask whoever's in there to give it to you so you can start doing these problems on your own. I hope this helped, and I will see you.